In this example, we have a compound shaft drives several pulleys as shown. So the segments 1 and 2 are hollow aluminum with a G and a J. Then the segment 3 and 4 are solid steel, a different material with different G and J. And the bearings shown allow the shaft to turn freely, meaning that no friction needs to be considered. So calculate the rotation angle, including correct sign of pulley D with respect to pulley B. Okay, so here we're not requesting you to calculate the deformation at the end point E. Right? We're only requesting you to calculate the rotation angle of pulley D with respect to pulley B. So what does that mean? So we're actually calculating what? Calculating the phi dB, right? D with respect to B. So I think from example 1, you have known something, right? If I request you to calculate the overall deformation at point E with respect to A, since A has been fixed end, so you should have known that to calculate phi E, right? You will just need to calculate phi 1 plus phi 2 plus phi 3 plus phi 4, right? So this is just our second equation, right? Our second equation that got phi equals sum TL over GJ, right? So this is our second equation. From that, you can derive, if we want to calculate the overall angle of twist, you just calculate all of these 4 sections and add them together. But how about phi dB? Phi dB is actually simpler, right? Since it only involves 2 segments. Okay, this is phi dB just equals phi phi 2 phi CB plus phi DC, right? Or phi 2 plus phi 3. Right, so we just need to calculate this 2, right? This BC and CD. And then each of them, you can just use a TL over GJ, then add them together, right? So this is how to solve this problem. Okay, let's solve it together. So as we just analyzed, the key is just to find what is phi 2, what is phi 3, right? Then we add them together. But to calculate each of the phi, we'll just need to know TL over GJ. G and J have been given, L has been known, right? So we just need to find out the T, the internal torques in these 2 segments. Okay, so how to determine this internal torques? Of course, we have to start from free body diagram, right? Okay, so look at the segment B, segment 2 first. So we just we cut segment BC to expose 2. Right? Okay, so if you cut it from here, make it free, then we will use the free part, the red part, right, without restraint. Okay, add it outward. So this is our T2. Okay, so we will draw this here, and you have a T2. Then at point C, you don't have anything, right? You don't have anything. So at point D and E, at point D, you have a TD. What is the direction? Your right hand rule. Curl your 4 fingers according to the direction of TD. Then the thumb will be pointing the direction of the double-headed arrow. Right? So it will be pointing left. This is TD, and TE pointing right. Okay, so we got a equilibrium equation that is negative T2 minus TD plus TE equals 0. So from here we can get T2 equals negative TD plus TE. This is negative 525 plus 175. That is negative 350 pounds feet. Okay, since this is the unit that have been given. Here is a pound feet, a pound foot, right? It's a, but since just examine the unit here, you can see that all the units have been given. So just inch to the fourth, psi, ksi, etc. Right? So we will not use pound foot. We will just convert it to pound inch. Right? So this will be negative just 350 times 12, right? 4,200 pound inch. Okay, then the next step, we will just cut CD, right? So we have determined T2. Okay, T2 has been here, so we also need to know T3. Right? How to calculate T3? We just cut it from here. I make it free and add T3. Okay, is this the same as T2? Since TC is nothing, at the point C you don't have any torque, right? So you will get exactly the same equation, right? So you will get the same equation as T2. So this will be easy, right? T3 equals negative 4,200 pound inch. Then in step 2, we will just calculate these two values for phi, or phi 2 and phi 3. And in these two parts, the two segments, we have different G and J values. Right, since one part is aluminum, the other part is steel. Right, so here there's a phi 2 will be just T2 L2 over G2 J2. That is negative 4,200 pound inch times L2 is 30 inch over G2 is 4,000 KSI, right? So we need PSI, pound and inch, right? Times 1,000 times J2 is 2.337 inch to the fourth. Okay, so here you should be clear why we need this 1,000, just a KSI to PSI. Again, I need to emphasize the importance of using consistent unit systems. Okay, so here in this example, we're just using the units like inch, PSI, pounds. Okay, these are consistent units. Okay, so the results will be negative 0.01347 radian. Then the phi 3 will be T3 L3 over G3 J3. This is the same value negative 4,200 times 40, right? Over 12,000 times 1,000 to convert KSI into PSI. Then times the J is very small, 0.497. Then we got a negative 0.02817 radian. Okay, then the result will be, as we analyzed it at the beginning, phi dB just equals phi 2 plus phi 3. You get, just add these two numbers together, negative 0.04164 radian.